Hello everyone. Today I'm going to introduce a quick adaptation to multi-vendor devices powered by the Agile Open Container, or AOC. Typically, enterprises use multi-vendor devices in their data centers and WANs. Due to different vendors using closed architecture systems, device adaptation and system integration depend on vendors. This leads to device adaptation usually taking 2 to 6 months, severely impeding service rollout. The AOC is an open system that enables customers to develop by themselves or through third parties. Using Netcomf or Yang, structured modeling languages and unified protocol standards, the AOC can automatically generate driver packages. By doing so, the development and commissioning of driver packages can be completed in just 1 day. Now let's look at the AOC. Open architectures in different industries are similar. The AOC to networks is just like the operating system to computers. Let me give you an example. To manage the hardware such as the mouse and keyboard through the operating system, you need to install corresponding drivers which enable the operating system to recognize the hardware. The AOC works in a similar way, except that it manages switches and routers instead of a mouse and keyboard. And to understand and manage these switches and routers, we need to load an NE driver, which is called the specific NE driver or SMD to the AOC. Then we can add and understand the specific capabilities of the devices. At the middle layer, the operating system implements hardware management. Again, we're talking about managing the status of mouse and keyboard. The AOC, on the other hand, implements any management such as managing any status and configurations. At the top layer, the operating system manages programs such as Word and Excel, and the mouse and keyboard are required for using these programs. The AOC implements service management at the top layer. In other words, it builds network services based on application scenarios. To facilitate O&M, the AOC also provides capabilities such as rollback upon transaction failure and automatic detection of device configuration changes. Next, let's move on to the concept of SMD in the AOC. So in the AOC, SMD packages can be classified into the following types based on the sources of Yang models. The first is Netcomf SMD Packages. A Netcomf SMD package can be used on Netcomf capable devices. It provides generic driver for converting Yang models to Netcomf packets. You can quickly customize a Netcomf SMD package for devices based on the Netcomf packet format. The second type is CLI SMD packages. A CLI SMD package can be used on devices that are operated via the CLI, such as old devices that do not support Netcomf. It provides a bidirectional rendering driver for converting Yang models to any CLIs. You can quickly customize a CLI SMD package for devices using the CLI. The third is Customized SMD Package. A customized SMD package can be used on devices that are connected in Customize mode. It provides a driver for converting a Yang model to non-Netconf model-driven protocols such as RESTconf. And you can quickly customize an SMD package based on the model-driven protocols supported by devices. Next, let's take a closer look at how to simplify SMD programming. The Yang file is the core of an SMD package. So how to quickly obtain a Yang file is a major challenge for SMD programming. You need to obtain a Yang file from the device vendor to create a Netcomf SMD package. Then you need to manually configure a Yang file using the CLI and conversion rules to create a CLI SMD package. But both of these are time consuming. The AOC provides Netcomf SMD Builder and CLI SMD Builder to make it much easier to obtain Yang files. It also supports syntax verification, tailoring and packing of Yang files. The Netcomf SMD Builder can be used for creating Netcomf SMD packages. For NEs that support RFC 6022, Yang files can be obtained from devices through Netconf. The Netcomf SMD Builder also supports the white box check, as well as tailoring and packing of the obtained Yang files. This helps to simplify Netcomf SMD programming. The CLI SMD Builder has been planned but not yet implemented, so I won't go into more detail here. Next, let's look at the process of using the Netcomf SMD Builder. On the package management page, enter the package tool page and click Creating a Plugin Package. You can use 2 methods to obtain a Yang model when creating a plugin package. The first is to import an existing Yang file. The second is to obtain a Yang model from a device. In this mode, you need to specify the IP address, port number and Netcomf username and password of the specified device. After that, we can tailor the full YANG file obtained from the device and implement white box check. If some issues are found in the YANG file, you can rectify the failures. These issues may be caused by some dependent YANG files not being selected during the import of the YANG file. After the alarms indicating failures have been cleared, click Making an SMD. An SMD package is now created. Finally, you can download the SMD package to the local computer. That's all for today's introduction to AOC-powered quick adaptation to multi-vendor devices. Thank you.